Welcome to Sravz technical series. In today's session, we will continue the discussion of the Boost-based REST API server. In the previous session, we had a high-level discussion of the code base, and we left some details for the today's session. So in this session, we will continue the discussion and wrap up the code review. So before we do that, we'll just go through the architecture diagram again. So in the Boost-based REST API server, in the previous session, we discussed that we added a router, then controllers and services. The services would call the corresponding backend database or AWS S3. So the router sits in the shared state, and the rest of the application accesses the router through the shared state, and to the router the request is passed, and the router, based on the request URL, accesses the calls the corresponding controller, and the controller uses the service to call the backend services, for example, MongoDB or AWS S3. So let's do a quick demo again. So this is the Thunder client. So we'll get some books. We had this discussion in the previous session already, so right now I'll just do a quick demo as a recap. Won't go in details. So we can get books. We can put books. We can post books. We can delete books. So deleted count too. So the CRUD create, request, update, delete works. So we'll go back to the code base and continue the discussion. So we discussed the session 1 source code. We'll continue with the session 2 source code. In the HTTPS session, some of the topics to be discussed in session 2 are the rest of the CRUD operations: create, update, delete, since we discussed get in the previous session. Then bearer token usage in the HTTP headers, in-depth discussion of the router, MongoDB controller, and MongoDB service. So in the HTTP session, now we validate the bearer token in the headers. So if you look at the Thunder client, in the auth headers, we are sending a bearer token, and the bearer token is passed from the environment variables. So we have a bearer token in the environment variable, and when we pass that in the headers, authentication header as a bearer token, the service validates the bearer token, and only if the token is valid, the request is processed. Now, for example, I update the bearer token to be an invalid token. For example, I put 1 in the front, save it, and then say get books, send. See, user is unauthorized because the token is invalid. So let me revert the change, save. Then we get books again. Okay, delete book. It worked. User is authorized. So the bearer token validation happens in the HTTP session class. So we use the Boost-based HTTP fields enum to check if the authorization header is there in the request. If it is there, greater than 0, we retrieve the authentication header from the request object by indexing into it, then strip out the bearer space in the beginning of the header. The bearer token starts with bearer space and then the value. Once we strip out those 7 character substring, we then do a JWT decode, and if the decode is successful, we return boost none. Else we return boost optional with whichever message it is, like API token expired, signature format, etc. So this was discussed in the rest of the code was discussed in this session, Boost based REST API server. So we'll skip that. So that's how we do the header verification. Then once the header is verified and the token is valid, we pass the request to the background worker thread, and the background worker thread would be called here. In the background worker thread, we pass the request to the route function in the router. We pass the request method, request URL, and request body. Then the router will process the URL and body and sends us back the HTTP code and the body in text format. So the HTTP code is used to create a response. HTTP code like 200, 201, 404, etc. And then the rest is already discussed, so we can skip that. So that is the change made to the HTTP session class. Now in the MongoDB controller, MongoDB controller.cpp, we use the MongoDB controller implements the get, post, put, delete methods, and these methods will call the corresponding methods on the MongoDB client. So like get is equal to find one, post is equal to insert many, put is equal to upsert, delete is equal to delete. And then the Mongo client will do the operations on MongoDB and return the response. So this is the header file for Mongo controller. It's just the same functions declared here. Now this is the router class. So in the previous session, we only discussed the get. Now in this version of the code, we have all the 4 HTTP verbs implemented. So we'll go over them quickly. In the HTTP session class, we pass verb, URI, and the request body to the route function. Then the route function will parse the URI and get the segments. Based on the segments, it will determine which controller to call. So the segment is this one. So for example, in this URL, MDB is for MongoDB. So we get MongoDB segment from the URL. Then if it is MongoDB, we call the MongoDB controller class. So for get, we pass the parameters. So we check the parameters. And once we have the parameters, we form a parameter JSON. From the parameters, we do it here. So you can look the implementation there. It's straightforward. Just get all the parameters from the URL, create a JSON object out of that parameter list. So the parameter will be key values in the URL. We'll convert that into a JSON object by using key as the key and value as the value for the JSON object. So that way we pass that to the MongoDB get method, and we get the documents from MongoDB controller, and then we pass that JSON from the route back to HTTP session, and the HTTP session will put that in the response body and send it back to the browser. Similarly, post. For post, we get the body of the request and we just pass it to the controller. Similarly, boost, beast, put we get the, so for put, for at least MongoDB, we have to add some extra parameters. So if you go to the put activity, put request, you see we need a filter to filter on. So we want to put on book 6, we are updating the description to this one. And we want to specify if we want to update one book or all the books in the collection. So the request body is different for put. So we do all that parsing of that request body here. We get the filter update one as a boolean, etc. And then we pass it to the put of the Mongo controller. Similarly, delete. The delete body is different. It has to have a filter. So we want to delete book 6. We want to delete one or all based on this flag. So we need to parse this body, which we did here. Once we parse that body, we pass it to Mongo controller, delete. So that's how that is done. Now, if you look at the return from this function, we are passing boost beast HTTP status and whether it's and a message and a string. The string could be, so the return is the HTTP status and a string, which is ideally a JSON string, which is sent back to the browser. And then we catch an exception, etc. If nothing is caught in the switch statement here, then we return not implemented unsupported service. So that's the router.cpp. The router.hpp declares that single route function, and yeah, this is the return type of the route function. So it's a pair of HTTP status and HTTP string. This string is used as which is a JSON string which is sent back to the browser by the HTTP session in the request body. So with that, we conclude the discussion of the Beast REST API server. We have discussed all four operations: create, update, delete, and request. So in the next session, we will continue the discussion of AWS S3 service. We will implement S3 select and then add the S3 select as a service to HTTP GET. So that way from the browser we can get data from S3 by using S3 select. And once we have that in place, we will implement some financial request on the financial data through S3 select. So with that, I'll conclude this session. Thank you.